Autonomous vehicle technology, what was once thought of as science fiction, is fast becoming reality. In the not-so-distant future, drones may be able to communicate with each other. Boeing has a new laboratory dedicated to building drones that work in teams. They can be used on the battlefield or in civilian life, helping victims survive natural disasters or conducting search and rescue missions. As Suzanne Vanderhoff shows us, the cutting-edge research is taking place inside Boeing's Collaborative Autonomous Systems Laboratory.
When you think of the Boeing company, the first thing that comes to mind is probably something like a 737 commercial airplane, an FA-18 Super Hornet military jet, or even a CST-100 Starliner space capsule. But inside this airplane hangar in St. Charles County, there's something else flying around. Unmanned autonomous vehicles, or UAVs, better known as drones.
We have 80,000 cubic feet of volume where we can track any object in our volume, both its position as well as its orientation or which way it's pointing, at a really, really high update rate and very, very accurately. Knowing that information, we can then command the vehicles to travel anywhere within the facility that we want.
The research facility is called the Collaborative Autonomous Systems Lab. It uses a series of cameras connected to a motion capture system, the same type of technology used for film or television motion capture animation.
The way that it works is there's little reflective markers on the vehicle, and the camera system that we have, the motion tracking system, is actually tracking the individual markers. You can see on the screen behind me, the cameras are actually tracking the individual markers. The system knows that a certain pattern of markers is an object, and so we're able to resolve, okay, you know, this is our quadcopter, this is our ground vehicle, this is maybe a second quadcopter, but it's vehicle A versus vehicle B.
Not only does the system allow the autonomous vehicles to communicate with one another, both in the air and on the ground, but the floor is actually a 30-foot by 30-foot projection screen that allows researchers to simulate the view of what it would look like if the vehicles were flying over real terrain.
We can really use it to project anything we'd like to on the floor. If we wanted to actually do real sensing with a real camera, we would probably fix the terrain, and then when the vehicle flies, we could actually detect objects and features on the ground for things like navigation or object tracking or that kind of thing.
And that's key moving forward, using autonomous vehicles for real-world applications.
One of the things that I think is definitely coming on that we'll continue to really focus on and really refine and improve is the collaborative nature of how these systems can work together, be it air, ground, and surface-based products or undersea products.
Another goal is to continue that collaboration and integration of UAVs into human-based activities.
In many cases, an autonomous capability is really required for what we call the 3 Ds of autonomy. Any job that is dull, dirty, or dangerous, we like to extract the human element out of that so that we don't endanger a human while performing those activities. If you have an earthquake and you have a major disaster, let's say you have a gas line that's now ruptured, you have rubble, and you don't know how to get to it, but you need to shut off that gas valve in order to create a safer environment for the rescue workers and everything else that's going on. Some of the ideas that we can test in here is how do we join a ground vehicle with an air vehicle which is equipped with a sensor that allows them to see what's the terrain, what is around the valve. How does it help this ground vehicle get to the valve?
And the engineers here say part of the fun and the challenge of their jobs is taking those ideas and the need for new technologies and trying to figure out solutions to other problems they haven't even thought of yet.
When I was young and PCs were first available, when you had a PC, it was really interesting and kind of fun to play with. But what they became really, really useful when we started connecting all of our PCs together and to bigger networks and the computers were working together. I think we're kind of on the cusp of that same kind of idea with the UAVs. An individual vehicle right now, you know, you can buy one, you can take it outside, it's great, it's fun to play with. But once we figure out how to get these vehicles working together, I think we're going to be able to do some really amazing things that we haven't even dreamed up yet.
For Innovations, I'm Suzanne Vanderhoff.